Section 8.3, again, review the PowerPoints located under the Resource tab. This time we are finding what's called the point estimate, and we're using that to calculate the interval. So for the given confidence interval and values of x and n, find the following. They give you a value of x of 46, n is 95, and they want you to use a confidence level of 80%. First thing you do is find the point estimate. The point estimate is equal to x divided by n. Notice it's the smaller number divided by the larger number. So 46 divided by 95, and the point estimate gives, when I do that division, I get 0.4842. This particular problem wants you to round to 4 decimal places. The next thing I want to do is find the standard error. The standard error formula, and again these formulas are on your formula sheet, it's equal to the square root of the point estimate times 1 minus the point estimate divided by n. So since I calculated my point estimate to be 0.4842, I'm going to take 0.4842 multiplied by 1 minus 0.4842. That takes care of the numerator under the square root, and divided by n. N is 95, so I divide that by 95. On the next calculation, I did the subtraction, 1 minus 0.4842, and I got 0.5158. Now I'm going to multiply the numerator, so I'm going to multiply 0.4842 times 0.5158. That gives me 0.2498. Then I'm going to take 0.2498 divided by 95, and that gives me 0.0026. Finally, I press the square root button, and my standard error comes out to 0.0513. The margin of error is going to need the critical z value times the standard error. So from the bottom of table A3, again that's that last line, if I go back, this is the bottom of table A3 right there, and I need to line that up with 80%, because that's what it said to in the problem, 80% confidence. So that lines up at a critical z value of 1.282. So the margin of error is going to be the critical z value times the standard error. So it's 1.282 times 0.0513, and that gives me a margin of error of 0.0658. This particular example takes it one step further and actually calculates the confidence interval. So they give me some more information. So given the data, construct a confidence interval for the population proportion P of the requested level. So they give me x is a 50, n is a 70, confidence level 99%. So if you look at the formula sheet, you see that the point estimate plus or minus the margin of error, that's what I'm looking for, but in terms of formulas, the point estimate is the P with the little hat on top of it, plus or minus the z critical value times the square root of the point estimate, 1 minus the point estimate divided by n. So the critical value, all of this in the formula here is the margin of error, and this is the point estimate. So first find the point estimate. The point estimate is x divided by n, or 50 divided by 70. This problem wants you to round to 6 places. So when I do 50 divided by 70, I get 0.714286. That's the point estimate. Now I go to calculate my margin of error. So I need the critical z value from the bottom of table A3 at 99%. So at 99%, that bottom number is 2.578 on the chart. Now I need to find the standard error, which is the square root of the point estimate times 1 minus the point estimate divided by n, which we did in the last example. So my point estimate number that I calculated right here is 0.714286 times 1 minus 0.714286 divided by 70. Again, n is 70. So when I do the subtraction, 1 minus 0.714286, I get 0.285714. Then I multiply 0.285714 times 0.714286. That gives me 0.20408. Then I take 0.20408, divide that by 70, and that gives me 0.002915. Finally, I take the square root of that number, and I get 0.053995. Again, they wanted to round to 6 places. So now you're going to take the
critical z value and multiply it. So it's 2.576 times 0.05399, and I get 0.139078. So I need to take the point estimate and subtract the margin of error, and take the point estimate and add the margin of error. So the point estimate is 0.714286 minus 0.139078, so I get 0.575. And on the upper end, 0.714286 plus 0.139078, and that gives me 0.853. So the answers then are the population proportion is greater than 0.575 and less than 0.853.
Another example, among 253 cell phone users, 110 said that their phones were Android phones. Find the point estimate. This problem breaks things down and wants you to type in the calculations as you're going through them. So first thing you do is your point estimate, x divided by n. So it's, again, the smaller number over the bigger number. So 110 divided by 253, and you get 0.435. So you would type that into the computer. Then it says construct a 99.8% confidence interval. So you use your point estimate that you just calculated. You have to find the critical z value at 99.8 or whatever percentage they give you. But for this particular problem, 99.8. At the bottom of A3 again, the critical value comes to 3.090. Then I'm going to calculate the margin of error. I'm going to use the critical value of 3.900 times, again, the square root of the point estimate, 1 minus the point estimate divided by n. So putting my numbers in, point estimate up here, 0.435 times 1 minus 0.435 divided by 253. So when I rewrote it here, when I do the 1 minus 0.435, I get 0.565 right here. Then I'm multiplying that by 0.435 to get 0.246. Then I'm going to take 0.246 divided by 253. That's a 3. 253, and I get 0.031. Finally, I multiply 0.031 times 3.090, and I get my margin of error to be 0.096. So I need to take the margin of error and subtract it from the point estimate and then add it to the point estimate. So when I subtract it, I get 0.339. When I add it, I get 0.531. So pretty much it's between 33.9% and 53.1% for the population. So it says assume 46% of cell phone users have an Android phone. Does this confidence interval contradict the claim? So pretty much what you do is you take the 46% and you either convert it to decimal 0.46, or you look at your other two numbers that you calculated as 33.9% or 53.1%. And is 46% in between those two numbers? Yes, it is in between the two numbers, so no, it does not contradict the claim because it's in between those two numbers. So again, if it's outside of those two numbers, it would contradict the claim.